Well, greetings, mathletes, and welcome to the first episode of Fall 2020. So we're going to start this semester off with a little review. We're going to start by looking at fractions, kind of hitting the high points with fractions, and then we're going to go into exponents in order of operations. So without any further ado, let's go ahead and start off with our fractions. Now, first of all, when you look at a fraction, and this is just to make sure we have all our parts named, the thing that's in the top part of this fraction is called the numerator. And this guy down here on the bottom is called the denominator. Okay, the denominator tells you what you have. Right? So in this case, we have thirds, right? The numerator tells me how many of those I have. So so the bottom tells me what I have, the top tells me how many you have, right? Of whatever you're talking about. So if you're talking about thirds, that means that it's an equal third. Something has been cut into 3 equal pieces. I am taking 2 of those thirds. And so you can think about it that way. And if you think about it that way, that actually does help some stuff out in the long run. And then the other thing here, this guy here is either called the fraction bar or the division bar. And despite popular belief, the fraction bar is not where fractions go for a drink. I know it's terrible. But nonetheless, let's go ahead, now that we have those parts named, let's go ahead and take a look at the next thing. So the next thing I'm going to need to do is reduce a fraction. Right? If I'm going to reduce, well, let's just take a look. Not everything reduces, but if it does, you typically are expected to put the fraction in reduced form. So if I have something like 5/7, if I want to try and reduce this, what I'm going to do is I'm going to look at both of these and try to find something that goes evenly into both of them. I'm looking for a number that goes evenly into both of them. And if I look at this, 2 doesn't go into either of them, 3 doesn't go into either of them, 4 doesn't go into either of them, 5 doesn't go into either of them. The only number that goes into both of them is 1. And if I try to divide out that 1, it's not going to change anything. So this is reduced. They have no common factors other than 1. Now, if I have something like this, right, these guys can reduce. And one of the things I like to do, and I'm just, like I said, I'm kind of giving you the quick review here. I know a lot of the time it's taught, find the greatest common factor between the two of them, divide both by the greatest common factor. And that definitely works, but sometimes it takes a while to find the greatest common factor. It turns out you can do this just by finding any factor and continuing the process. So looking at this, if I don't automatically see what the greatest common factor is, I'm going to divide out a factor. These are both even numbers, which means 2 goes in. If I divide both by 2, I get 20/8. Right? Well, what you do now, and it's because you just found any factor, you're not necessarily reduced. You look at it one more time and try to find something else that goes into it. Let's see here. It looks like 2 will go in again. So I'm going to divide it by 2 one more time. That's going to give me 10/4. Okay, and then let's do this one more time. Because both of these are still even. I'm going to divide it by 2 one more time, and that's going to give me 5/2. And so you notice it was a little bit longer process. At least I wrote down more, but each step is a little more bite-sized. And so if you just want to do it in steps, this is a good way to go. I don't know. Let's look at another example. Let me erase this one. Okay, so let's go ahead and take a look at, let's see here, 60 over, do I want to do that one? Yeah, let's do 60 over 42. We'll start there. That seems like a good one to start with. Um, in fact, this is probably a good time. See if you can reduce it. Go ahead and pause the video here, and then I'll finish it after you've paused it. I finished it after you have. So go ahead and play the video when you're done working it out, and then see if we match up. So pause here. Okay. Now let's see what we can get out of this. Now I'm looking at this, and once again, I do see that they are both even. And so I'm going to divide by 2. So that's going to give me 30. And if I divide 42 by 2, that gives me 21. Okay, so I go to use my 2 trick again, and it turns out they're not both even. So 2 goes into the numerator, but not the denominator. So we have to check to see if anything else goes in. And looking at this, the factors of the denominator are 3 and 7, and it turns out 3 goes into the numerator as well. So we're going to divide that. So now we're going to divide 3. Now, if I do that, I end up with 10 over 7. And I look at this last step that I just finished, and I check to see if anything else goes in. 7 is prime, and 7 does not go into 10, which means that it's not going to reduce anymore. And by the way, don't make the mistake of thinking that a mixed number is what it means when I say reduce. Reduce just means that you have a single fraction that has no common factors between the numerator and denominator other than 1. Okay, so an improper fraction in and of itself is not actually anything improper. It's just an unfortunate name. And I want to point out something else here too. When we do this, like in the last time we divided by 2 3 times, right? Well, if I multiply 2 by itself 3 times, that gives me 8, and that actually was the greatest common factor. If we look here, between 60 and 42, the greatest common factor is 6. If you happen to spot that, you could have jumped straight to the answer, right? If I just divided by 6, I would have gotten 10 over 7 right away. And the thing is, we did divide by 6. 2 times 3 is 6. So even when you're doing this in pieces, you're still dividing by the greatest common factor. You're just doing it a little bit slower in more bite-sized chunks, right? And so this would be your answer here. So hopefully you guys got that right. Okay. Okay, so let's go ahead and erase this. And that's the main thing I wanted you guys to get out of this. And we will take a look at, we'll be doing plenty of that along the way, but we're going to take a look at the next thing on the list here, which would be multiplication and division. Now, multiplication is the next thing we're talking about. No, let's try it with the pen on. Let's try this again. There we go. Right? So if we're talking about multiplication, the process for multiplication is really straightforward. It's probably one of the most straightforward things you can do with fractions. And it basically works like this. If I have 2 fractions, oops, not equals, and I want to multiply them together. Basically what you do is you multiply straight across. So I multiply the numerators. A times C is AC, and B times D is BD. Oop, that's not a B. I think the internet's making me dyslexic. Okay, so BD. There we go. Yeah, and that's honestly, that is the definition. Now, what you're expected to do, though, is at the end, this is expected to be reduced, right? And so there's 2 ways we can handle that. You can multiply things straight across and then reduce at the end, or there's actually a way to reduce before you multiply so that you don't have to worry about it. So we'll go ahead and look at both. If I have something like, oh, I don't know, 6, let's make it interesting. 6 20ths times, let's see, 8 8/9. Okay, so let's say we're looking at that, right? I didn't want the multiplication to get too bad. Um, so if we're going to follow this definition here, really all we need to do is just multiply straight across. 6 times 8 is 48, and 20 times 18 is 180. So at this point that is an answer, but like I said, you're expected to have reduced it. So that's what we'll do. And I'm just going to start right here by dividing by 2 on both of these. If I divide both of these by 2, I get 24 over 90. They're both still even, so that gives me 12 over 45. And it looks like 3 goes into both of them. So that would be 4 over 15. And now I don't have anything else that's common. And so I end up with 4/15 as my final answer for that product. Okay, so you notice I had to reduce at the end. Now, there's another way to do this. And I'm just going to rewrite this problem. Let me move this around. I got to be able to get to my colors. Okay, so let's look at 6/20 again times 8/9. So we've already seen it with the multiply straight across thing. What we're going to do now is we're going to cross cancel. Now this often gets mixed up with cross multiplying. This is cross canceling. And it's confusing because of the words. You use cross canceling when you multiply. You use cross multiplying when you solve a proportion. And so because both of the descriptions have the word multiply in it, it's often confused. So here we are canceling because what we're doing is we're reducing the problem before we do the multiplication. So what I'm going to do here is I'm going to look for anything that there is that's common between any numerator and any denominator, right? So that includes stuff that's inside the same fraction. So like here, 6 over 20 can reduce by 2. So I'm just going to do that here. So I divided both of those by 2. Now I'm going to keep looking. 10 and 8 have a common factor of 2. So I'm going to divide that out. I'll divide out that 2, and that gives me a 4. And then lastly, 3 and 9 have a common factor of 3. So this 3 now becomes a 1 because I divided it by 3, and 9 gets divided by 3 to become a 3. Right? Now, what I do is I multiply everything that's left. 1 times 4 is 4, and 5 times 3 is 15. And so you see, you kept all your reducing over here on this side. Right? So it's a little more compact. Both ways are absolutely 100% correct. But no matter which way you do it, you are expected to come up with this answer. Okay? All right, so let's take a look at one more here. And I'm just going to get this whole business off of here. There we are. Excuse me. Sorry, I had to refuel there for a second. Okay, so this one is for you to try, just to kind of make sure that you understand the procedures and all that kind of stuff. And so let's see how you do with it. So let's say I have 25 over 14 times 49 over 20. Okay, so I want you to take a second. Go ahead and work it out either direction. I don't care which way you do it, but see what you get. So go ahead and pause now. Okay, so let's go ahead and take a look at our solution. Now, I'm going to go ahead and cancel these things out ahead of time, but you should get the same answer no matter which way you did it. So again, I'm looking for any common factors between numerators and denominators. I notice right away 14 and 49 have a common factor of 7. So if I divide that by 7, I get 2. I divide that by 7, I get 7. And then that's done there. But if I look around here, I can see that 25 and 20 both have a common factor of 5. So I'm going to divide those by 5. And then I'm going to multiply out what I have left. 5 times 7 is 35. 2 times 4 is 8. And one of the things I want to point out here is that when you're looking at this, if you had gone the direction of 25 times 49, those would have been some really, really, really large numbers. 14 times 20 is a little more bite-sized, but it's still a large number. So, this tends to save you a lot of arithmetic, right? That's the main thing that I want you guys to be able to do here, is do it the way that makes sense to you. And hopefully in the long run, you'll understand the shortcuts and be able to save yourself a lot of time. Okay, so what I want to do now is go ahead and take a look at division, because division is very closely linked with multiplication. First of all divisions can be written as multiplication. And it's because division is the inverse function for multiplication. So if I have something like 25 divided by 5, I can actually rewrite that as 25 times 1/5. And then if I need to multiply those out, I can actually do this, right? And now I have two fractions. I can cross cancel. So I'll end up with the same answer no matter which way I do it. 25 divided by 5 is 5. I suppose some of you are thinking about your ma and pa kettle right now. Yeah, believe it or not, the answer is not 14. But hopefully you get the idea here. Every division can be rewritten as a multiplication, which means division and multiplication are actually the same thing. And that idea is very important when we get to the order of operations, because what it ends up meaning is that neither one of them is more important than the other, right? So division isn't more important than multiplication, and multiplication is not more important than division. They're actually the same thing. So that's the main idea there. That's what's actually going on. If I'm going to define this thing, let me go ahead and erase that and then switch back to that. If I'm going to define this, if I'm going to divide two fractions, right? A over B divided by C over D. What I end up doing is flipping the second one and multiplying them across. So this is actually, in fact, let me do this. Get that thing off of there. I was just trying to point. I can rewrite the problem as a multiplication problem. So what you do is when you have division, you flip the second one, right? And now you can multiply. So if you know how to, if you know how to multiply, you should be able to divide. And really the only thing that changes here is that you take the reciprocal by flipping this fraction over. One's C over D, the other's D over C. And your final answer, still you have to multiply everything out. But it still turns it into the previous kind of problem, right? So our strategy for division is to just turn it into multiplication. Where'd it go? There. Okay. So yeah, if I have something like, I don't know, 7 over 50 divided by, let's say 14 over 25, right? If I have something like this, my immediate strategy, and by the way, there are other ways to do this, but this is the typical one. My immediate try that again. Blah, blah. My immediate strategy is to flip the second fraction. So I'm going to have 7/50ths again. That doesn't change. But we do multiply the second one. So 25, or flip the second one. So we get 25 over 14 here. And now we can just start hacking and slashing. Let me get this out of the, there. I want to get this out of the way. There we are. So if I'm going to start slashing this thing up, let's see, 25 goes into 50 twice. It goes into itself once. Oh, look at this. 7 goes into 7 one time and goes into 14 twice. And so if I go ahead and multiply straight across here, I end up with 1 over 4. And you notice, as long as I get all the common factors in this area, this answer will be reduced at the end. It's actually kind of nice that way. So, okay, so let's see here. Let's do that. And I am going to get rid of that. And then let's go ahead and take a look at one more for you to look at. So again, pause this once I get it written down, and then we'll take a look at it. We'll look at my solution, and hopefully yours will match up with mine. So this one I'm going to challenge you a little bit more. Let's go ahead and take a look at, well, let's do this in black. So let's take a look at 5/12 divided by 15/18 times, oh yeah, I'm throwing another one in there because I'm crazy. Oh, what kind of goodness. Let's do 9/8. Yeah, we'll see what we get out of that. Okay, so go ahead and pause it, and then we'll look at our answer afterwards. Okay, so we're ready to go here. Now, I'm imagining the thing that probably, if anything, caused you problems, it was probably the fact that this middle term, I have a division here and a multiplication here. The way you handle these is you go ahead and turn everything into multiplication. A lot of people are mistaken because they think the order of operations says that multiplication comes first when you're talking about multiplication and division. That is not the case. It sometimes comes first. But the fact that multiplication and division are the same thing, what it really means is that whatever comes first, left to right, is what you end up computing first. And so the easiest way to handle this is to just flip any fractions that are being divided and then proceed with multiplication. So 5/12 is not going to change, right? So we got 5/12 here. Whoop, that's not a 12. Try that again. So we got 5/12. 15/18 is being divided. So that means I'm going to turn it into multiplication and flip it. And then the last term here is not being divided, right? It's being multiplied. So we're going to leave it as multiplication. Then from here, we can just start hacking and slashing. And I want to make sure it's clear. You don't, when it's all multiplication, there's no additions or subtractions in there. There's no parentheses or exponents. It's just multiplication. You can cancel as far as you want. So for example, here between I could cancel between the 12 and the 18, but the 12 and the 9 have a common factor of 3. So I can actually start by doing this, right? They don't have to be next to each other. Okay, so let's see, what do we have next here? Oh, the 5 and the 15, so that's a 1, that's a 3. And that means I can cancel the 3's out, so those are 1's now. And then 2 goes into 8, and 2 goes into 18. And I think I have everything now as I'm looking at this. So all I have to do now is multiply straight across. 1 times 9 times 1 is 9. And 4 times 1 times 4 is 16. Right? And so that ends up being our answer. That doesn't reduce anymore. There's nothing that divides into both 9 and 16 at the same time. Right? So hopefully you were successful with that. That one I actually pushed the gap a little bit. I pushed you a little bit farther than what I had done in examples. So good. So that is addition, or excuse me, that is division and multiplication. And now for our next part. Okay, so now we need to talk about addition and subtraction. And sorry, I'm being distracted by my cat. Say hello, Momo. Say hello to everyone. Okay, or don't. Okay. Anyways, back to math. um, yeah, so we're talking about addition and subtraction. Sorry, I'm going to blame Momo on that one. Yeah, addition and subtraction. There we go. Okay, so addition and subtraction is also fairly straightforward as far as its pure definition. Um, remember what we talked about at the beginning, that the excuse me, the denominator tells you what you have, and the numerator tells you how many you have. And so if you're going to add things together, what you have has to be the same thing. And so that means that there's a common denominator. So if I have something like, I don't know, 4/5 plus 9/5, right? If I add those together, I have fifths. And if you just think about it in terms of how you say it, I have 4 of these fifths, I have 9 of these fifths. How many fifths do I have? Well, you have 13 of those fifths, right? And that's really what the basics of addition and subtraction are. I mean, we could switch this too. I could switch it to subtraction just as easily. In which case, I have 4 of these fifths and I'm taking away 9 of these fifths. If I do that, I end up with -5 of these fifths. And on top of that, that leaves me something I can reduce, right? Because -5 divided by 5 is going to be -1, right? It's a negative divided by a negative, so that makes it positive, and it's a number divided by a negative divided by a positive, that makes it negative, and then the number basically divided by itself gives you the 1. So, yeah, you after you do the addition, you still are expected to what do you call it, to reduce it after you're done. Okay, now, well, that's just not as efficient, is it? All right. Now, in the case where we don't have a common denominator, so let's say I have 3/5 and I want to add that to 2/15, right? So the problem is I don't have the same thing. It's like I have 3 apples and I have 2 oranges. You can't say you have 5 of something because they're different things, right? You have, I suppose you can categorize them as fruit or something like that, but that doesn't work here in the math. We actually have to make those denominators equal to be able to play around with this. And so the process is actually the reverse of reducing. When I'm reducing, if I have something like 12/18, I'm dividing the numerator and denominator by something, right? That gives me 2/3. Um, but if I'm going to find a common denominator, typically what I do is I'm multiplying the numerator and denominator by the same thing. And so again, it's because division and multiplication are the same operation basically. So what I want to do is I want to see if is there a number that I can turn both of these denominators into. And because 5 is a factor of 15, I can multiply 5 by 3 to get a 15. So that's what I'm going to do. But rules of fractions say you can't do it to the bottom unless you're going to do it to the top two, right? It's kind of like having 2 kids and there's toys on the shelf. You really can't get a toy for one unless you're going to buy 2 of them and give one to each, or cookies or whatever. Math is a lot like parenting. Anyways, so once I do this, 3 times 3 is going to give me 9. 5 times 3 gives me 15, and that means that it matches now. Once it matches, you can add the numerators. So this gives me 11/15 and we're good to go from there, right? Okay, so let's go ahead and get rid of this, and we'll take a look at another example here. Where to go? That's what I wanted. Okay, and you're going to have to forgive me. The gardeners just showed up at the apartment complex, so there may be some noise outside. Hopefully it's not too distracting. All right, now the next case here, well, let's just take a look at it. Let's say I have, oh, probably easier to take a look at it if I actually have a drawing tool open. Yeah, let's say I'm trying to add 5/12. Let's make it subtraction just so we can mix it up a little bit. And let's see here, 4/30. Actually, let's not make it 4/30. Let's change that numerator. Let's get something that won't go in there. How about 7/30? There we go. I didn't want them to reduce. Okay, so if we're going to subtract these, we have to find a common denominator, right? And it's probably not super obvious right now. So here's what I like to do. I like to list the multiples of both denominators. Because if you think about the greatest common factor, or excuse me, least common multiple, that's actually what we're after. The common denominator is going to be your least common multiple. So if we write out multiples, right, if we go, let's start with 12. And keep in mind, this is actually stuff that you would be doing in your head. Now you got 12, 24, 36, 48. I'm just going to write out a few. And basically what I'm doing is I'm going to keep going on both of these until I have a factor that's a multiple that's in both lists. 30, we'll go from 30, let's see, 60, 90, 120. Okay, so I'm not seeing any matches here, so we're going to have to keep going. The next one would be 60. Oh, there we go. There's our match. Right? So, oh. Wow. Let's try this one more time. And there we go. That should be there. That should be what I'm trying to circle. So 60 is our common denominator, right? And this is how you generally do it in your head. You just start listing multiples until you get things that match up. So now that we know we have a common denominator of 60, we're going to rewrite both factors, or excuse me, both fractions with a denominator of 60. So to go from 12 to 60, well, if you wrote these things down in order, you can actually just count it out. 1, 2, 3, 4, 5, so it's 12 times 5. So that's times 5, which means I have to do it there too. So that's 25 out of 60. And then over here, you notice 60 is the second on the list, which means it's 30 times 2, although you guys probably knew that, which means that this 7 times 2 is going to give me a 14. So if I have 25 minus 14, that gives me 11. And so I get 11 over 60. I need to check to see if it reduces, right? 60 has a lot of factors. It's probably easier to check 11. 11 has 1 and 11 as factors, and 11 doesn't go into 60. So that means that this is reduced, right? And that's the idea here. So I want to do one more here. Let's go ahead and clear this stuff out. And there we go. And this one I'm actually going to bump it up to 3. So let's see what we got here. Let's do 7 over 15. Actually, minus 5 over 12 plus let's do 11 over 30. Okay, so we're going to see how you do with this one. So go ahead and pause here. All right, so let's take a look at what we got. So this time we have three denominators. Now, it does help to know your multiplication tables, first of all, but let's go ahead. I'm going to start with the biggest one. We actually already know that 12 and 30 have a common factor of 60 from the last time. So let's go ahead and take a look at this. So we got 30, 60, 90, and then 12 goes 12, 24, 36, 48, 60. So 60 is my hope. So far it matches up. That's one thing that matches up. Let's look at 15 now. So I got 15, 30, 45, and 60. So it's going to be 60. 60 is the one thing that's on all three lists. And keep in mind, again, you're usually doing this stuff in your head, but sometimes when the numbers get bigger, it's easier to just write it all out. So that means that we have to rewrite this. Let's see, it was 15, so let's see, 1, 2, 3, 4. 15 times 4 is 60. And actually, if you ever look at an analog clock, a quarter of an hour is 60 minutes. A quarter of 60 minutes is 15 minutes. That's, so clocks actually do help quite a bit. In any case, that means we're doing 60 times, or 15 times 4. So that means times 4 there. 12 was times 5. And 30 is times 2. Right? And so we just need to multiply these guys out and figure out what we got. There we go. So let's see here. That would give me 7 times 4 is 28. So I have 28 over 60 minus 25 over 60 plus 22 over 60, right? And so this is what we're trying to compute now. Now, the other thing I want to point out, this is just like with multiplication and division. Addition and subtraction are actually the same thing, right? You can always add the negative to turn a subtraction into an addition. And so neither one of them has precedent over the other, right? Subtraction could come first, addition could come first. It depends how they're listed left to right. So what we're going to do is move across here, right? We'll just do these numerators one at a time and figure out where we're going from there. So I have a common denominator of 60 here. And so I just need to go 28 minus 25 gives me 3/60. And now I have this other piece that I'm going to bring down. 3 plus 22 is 25. So that's 25 over 60. And now I have it down to one fraction, but I do have to make sure that it doesn't reduce. And so I'm looking at this, and 25 has 5 and 25 as possibilities. 5 goes into 60 because it ends in a 0. So that means I can divide both of these by 5. In fact, 5 times 12 is 60 anyways. We were just looking at that. Okay, so 25 divided by 5 is 5. 60 divided by 5, we actually did that over here. That's 12. And so I end up with 5/12, right? Nothing else will reduce there. Okay, well, I'm looking at the time right now, and we do still have a little bit more to cover, but I'm going to be up against office hours here real quick. So what we will do is go ahead and end this video here and continue it in a second video. And so you'll have 2 videos on this playlist. In any case, I will see you guys in the next video, and carry on.